So today's lesson is going to be on manometers. And manometers are a way that we can use to measure the pressure of gases. Manometers can be one of two ways. They can be closed, like in this first example. Okay? So in this example, they are closed. So the height of this liquid, usually we use mercury, all right, in a manometer because of its properties, and it is a liquid at room temperature, and so it's really good for manometer use. Okay, the height of this mercury in this case, because it's closed, is going to be the pressure of the gas itself. So basically we have gas inside of a system. We do have the atmosphere around us pushing down, but because this is a closed system, there is no interaction between the atmosphere and this mercury. So the height of the mercury is just the pressure of gas. It asked me to put it in atmospheres. So I have 82.2 centimeters. If centimeters is on top, it goes on bottom. I know that 1 meter is 100 centimeters. And from there, I can go to millimeters, where 1 meter is 1,000 millimeters. And now I am in millimeters of mercury, so I have gone from centimeters to millimeters. And from millimeters of mercury, I can then go to atmospheres, where I am asked where 1 atmosphere is 760 millimeters of mercury. I plug that in, and I get 1.08 atmospheres. So closed systems are pretty straightforward and basic, okay? So let's do another, pause the video, try this second closed system. You know it's closed because of, you can tell here it's not open. Let me show you what an open one looks like. Number 3 is open, so you can tell the difference between an open and a closed. Pause this video, try number 2. Okay, so we are asked for kilopascals. The height difference here between the manometer is the pressure of the gas because it is a closed system, so the atmosphere is not able to interact. So 740 millimeters of mercury. If that is on top, it's going to go on bottom. It does ask me to go to kilopascals, and I know 101.325 kilopascals is 760 millimeters of mercury, which is 99. Let me plug this in and do my rule of 3 here. .7 kilopascals. So, number 3 is where it gets a little bit more tricky. Okay, once we have an open system, the atmosphere around it is going to interact. So the atmosphere is now able to push down. So I have 2 parts to this system. I have the gas part and I have the atmosphere part. And the gas is pushing down on the mercury. The atmosphere is pushing down on the mercury. So the question becomes, which one has more pressure? All right. And the way I like to think about it is sort of like a scale. Okay. So if you see here, the mercury is higher than the mercury on this side. So this gaseous mercury is higher than the atmosphere. So you know the atmosphere has won. It has pushed the mercury up towards the gas. So the atmosphere is a higher pressure than that of a gas. And I think of it like a scale. And let me see if I can't zoom out here and use my hands to kind of try and make this work for us. Okay. So I have the gas and I have the atmosphere. When the atmosphere is pushing greater, my gas is going up. If the gas was greater, the atmosphere line would be higher. Okay? So we are going to solve for this. All right. The total pressure, all right, is going to equal the pressure. So what? Okay. So let me start over. So what is bigger, the gas or the atmosphere? The atmosphere is larger. Okay, so my atmospheric pressure is 735 millimeters of mercury. It is pushing the gas or the mercury back up towards the gas. So here's the pressure of the gas, 24 is in centimeters. So step one, I'm going to have to convert this into millimeters of mercury because my atmospheric pressure is 735. So centimeters, if centimeters is on top, it goes on bottom. 1 meter is 100 centimeters. I can then go to millimeters, where 1 meter is 1,000 millimeters. All right, so when I convert that, I am going to end up with 240 millimeters of mercury. Yes? All right, so because my atmospheric pressure is 735, and my gas is 240, and the atmosphere is greater, we are going to subtract to find our pressure. So the pressure of the gas is going to be 735 minus the pressure in the manometer. And so the pressure of the gas in this case is going to be 495 millimeters of mercury, which I have to convert into torr. So it is 495 torr. All right, let's look at number 4. In number 4, we notice the pressure, this pressure or the mercury is higher. So the gas pressure has to be greater than the atmospheric pressure, okay, because the gas is pushing and able to push this mercury back up toward the atmosphere. So if we want to find the pressure of the gas for this particular one, all right, the way we're going to work this out, the pressure of the gas has to be greater than that of the atmosphere. All right, so if this is 463 millimeters of mercury, and this is 805 millimeters of mercury, what do I have? So basically, here's my gas. It equals the pressure of 463 plus 805. Because if the gas is a larger number, the only way to take these two values and get a larger value than 805 is to add them together. So this is kind of how I solve them. So there's different ways to solve manometer problems, but to me, it just makes intrinsic sense to decide whether I need to add or subtract. Is my gas greater? In which case I add. Is it less? Which case I subtract. So this gives me 1,268 millimeters of mercury, but it asked me to put it into atmospheres. So if millimeter of mercury is on top, it goes on bottom. I can go direct to atmospheres, where 1 atmosphere equals 760 millimeters of mercury. So when I divide that bad boy by 760, I get 1.67 atmospheres. All right, let's try the next one. What is the pressure of the gas in the manometer in kilopascals if the atmospheric pressure is 97.8? So in this case, the atmospheric pressure is greater than the gas. I know that because my mercury is moving towards the gas part. All right, so the pressure of the gas is going to be smaller than the pressure of the atmosphere. So the only way for me to get a smaller number with these two values is to subtract. Okay, so 132 is in millimeters of mercury. So my first step, I have to convert this into kilopascals. Where 101.325 kilopascals equals 760 millimeters of mercury. And so when I do that, I get a value. Let's see, let me plug that into my calculator. I get this value of 17.5986 kilopascals. And again, we're not going to round until the end, okay? Rounding leads to errors. So if my gas is going to be less than 97.8, I have to subtract these two values. So when I subtract these two values, and I'm sticking with my rule of three, 80.2 kilopascals is the pressure of the gas. So essentially what we've got going on here is a total pressure. The sum of the parts equals the total pressure. Okay, so the sum of the gas and the mercury within it will equal the atmospheric pressure. All right, so the sum of the gas plus this mercury equals the atmospheric pressure. All right, let's do one more example. What is the atmospheric pressure? And we're going to put it in atmospheres. If the pressure of the gas is 1350. So when I look at my mercury, I can tell the gas is greater than the gas of the atmosphere because my mercury is pushing up towards the atmosphere. So it's almost like a competition. The gas is winning. It is pushing up. So I need my atmospheric pressure to be less than the gas in the manometer. So this is my gas right here, 1350 millimeters of mercury. So I need my atmosphere to be less than. So I am going to subtract these two, all right, because the atmosphere plus the mercury will equal my gas. So 1350 millimeters of mercury minus 773 millimeters of mercury is going to give me 577 millimeters of mercury. Now, this is my atmosphere. Now, I'm going to go ahead and ask me the pressure in atmospheres. So I'm just going to convert this into atmospheres. 1 atmosphere equals 760. And that is 0.759 atmospheres. Okay, so when we work these out, we need to be careful, pay attention. Do they give you the pressure of the gas like they did in number 6? Or did they give you the pressure of the atmosphere like we did in the first couple? All right, but ultimately this is still a total, all right, Dalton's law of partial pressure. The total pressure equals the sum of those parts.